So, hello everybody. Good morning for you, good afternoon and good evening, depending on where you are coming from. Again, we have a very international audience. I'm happy about that. Thank you for your time. This is the last seminar of our series in November for the food and beverage industry of Endress Hauser. Today, we like to talk a bit about level and pressure measurement and how these measurements ensure food safety and quality in your plant. Let me introduce first how the GoToWebinar panel works. You can increase and decrease the webcam, so the window, to make the presentation a little bit bigger according to your needs. And then in the system, you can download the already uploaded presentation. So the presentation you are going to see in the next hour is already there. And please just use the download link there to download the file. You can use this presentation for your own needs, but you can give this as well to colleagues or to friends where you maybe know that they are interested as well, or maybe to colleagues who had not the time to see this seminar. In case of any questions, do not hesitate to ask your question directly in the chat box. We will either type then the answer in the chat box for you, or we discuss the questions at the very end of the seminar. But just write the questions immediately in. And again, the session will be recorded. That means you can see the seminar also afterwards in about, let's say, beginning of next week. We might be finished with the uploading of the recording. So then you can see the session again, if you like to see it again, or in case you know someone who like to see it, just go to Endress, to www.endress.com to find it. But I will show it later on a little bit more. Who is your presenter of today? That's me. My name is Matthias Schützeberg. I am the Industry Development Manager for Food and Beverage at Endress Hauser Group Services in Switzerland. But I am just the moderator for today. The speaker for today is Ralf Knall. Ralf Knall is the Industry Manager for Food and Beverage in the Production Center for Level and Pressure. So he comes directly from Marburg, Germany. That's it for now from my side. So I give over to Ralf. Ralf, floor is yours. Thank you very much.
Thank you, Matthias, for the introduction. Welcome also from my side, ladies and gentlemen. As mentioned already, my name is Ralf Knall. I'm Industry Business Development Manager at our production facility for level and pressure instruments in Germany, in the very southern part of Germany, close to the Black Forest. We have a beautiful village called Maulburg, and this little village with about 4,000 inhabitants is called the City of Level and Pressure, because a big part of the whole city actually is Endress Hauser. Here you can see a picture of the campus. We have in total about 100,000 square meters of production, office and logistics area. Here in the foreground you can see our latest production buildings, which have been finished mid of this year, and I'm situated in this production center, which is responsible for level and pressure instruments. We have also subsidiaries in different places in the world, in India, in China, in Japan, USA, and Brazil. You will find also production sites of Endress Hauser which assemble products for the local markets. Coming to the topic, level and pressure measurement in the food and beverage industry, how to improve hygienic safety and gain efficiency with our instrumentation in your application. This is the topic, and I would like to start with a very typical application that most of you probably will see in their plants, which is the application. Excuse me, I just have a pop-up here. I need to close this. Okay, so an application in a cold medium. So may it be milk, may it be beer, or also soft drinks. So these applications are actually across the board. You can find this, and what do they have in common? What is a challenge that most of the applications face? Actually, the condensation. Due to the fact that the process is much colder than normal atmospheric conditions or ambient conditions, you will find condensate all over the place. Normally, of course, the tanks are insulated, also pipes are insulated to reduce energy costs, but in many cases the instruments are not. We also don't recommend to insulate the instruments up to the top, because then they are completely exposed to the cold environment. And especially when we take into consideration pressure transmitters, which are normally used for hydrostatic level measurement in beer tanks, in milk tanks, then this condensate has also an effect on the performance of the device. And I'm going to explain you why this is the case. Yeah, when you look at a normal gauge pressure transmitter, which is normally used, so we normally measure the hydrostatic pressure in a tank compared to the atmospheric pressure, we need a gauge transmitter. And the gauge transmitter normally needs to have a compensation for the atmosphere. You can see it here in the middle. The backside of the piezoresistive sensor chip needs to breathe, as we say. So there needs to be a compensation to the atmosphere. Normally, it goes into the inside of the instrument, and there is a Gore-Tex filter which makes sure that the path is open towards the sensor. Problematic when you have low temperatures in the process is that you will have condensation which forms normally outside of the housing, unless, for example, cable glands are not locked or closed carefully, or also the display or device covers are also not closed in the right way. So you need to make sure that these are always tight. But the Gore-Tex filter actually is also used to make sure that the air will not contain water. This is to a certain extent possible, but if you use a Gore-Tex filter for your clothes, for example, so Gore-Tex clothes, you know that the water drops from the rain will not move inside, but if you start to sweat and the dust can migrate through a Gore-Tex filter. So this means a Gore-Tex filter is never completely watertight. When you have a pressure transmitter and it's operating in your processes, normally you have cold processing cycles and high temperature for the cleanings. And due to this temperature changes all the time, you generate a kind of pumping effect inside the housing of the transmitter. This pumping effect is actually just a kind of expansion and contraction of the air due to the temperature changes, and due to these expansion and contraction, the water molecules will move into the device. And over time, some liquid may accumulate here at the bottom of the housing and generate malfunctions. And Endress Hauser has developed actually two pressure technologies which feature the Con-Tight technology. So Con-Tight stands for condensation tight, and as the name indicates, this technology makes sure that no moisture will move into the sensitive sensor part and harm the function. So the Con-Tight technology is available for two technologies. There is sensors with metal membranes, such as Delta Pilot FMB50 and FMB70, and also for sensors with ceramic membrane. The function of the contact sensor with metal membrane is based on a hermetically sealed sensor design. So besides the process membrane, we use an additional membrane also for the compensation of the atmospheric pressure. With this design, the sensitive piezoresistive sensor, which you can see here in the center, is completely encapsulated and moisture is fully excluded. We have an installed base of about 500,000 devices of FMB50, FMB70 Delta pilots out in the market because we started to develop this technology already more than 20 years ago and improved it step by step. So benefits of this technology, of course, first of all, the condensation resistance guarantees highest process availability and reliability. Secondly, due to the very good temperature shock behavior, this device can recover after cleaning cycles very quickly. So this means you can run your next production cycle very fast and don't lose too much time between the process and the cleaning cycles. Also, we use a Hastelloy C membrane, which guarantees a long sensor lifetime, especially it is resistant against cleaning agents. The construction of the device, of course, is completely compliant to the current regulations from 3A and EHEDG, and we also comply to the food contact material standards, may it be the Americans or the European or the Asian requirements. So also the OPEX costs can be reduced because you can reduce calibration intervals. The sensor is very stable, so it doesn't have a long or it has a very good long-term stability and a 0-point stability. The batch-to-batch repeatability with high accuracy and reliability is also proven. On the other hand, the construction of the ceramic sensor based on the contact technology, this is a little bit realized differently. In this case, we use a moisture absorbent technology, which absorbs moisture that finds its way into the inside of the ceramic sensor. Here on the left side, you see the basic construction of the ceramic sensor. We use two plates. They are electrically conductive and form a capacitor. And if we apply the pressure, the process pressure to the membrane, which is made of ceramic, the distance between these two plates will be reduced and the capacitance will increase. And this capacitance increase is proportional to the applied pressure. Also, this technology is available for atmospheric or for gauge and relative applications with this atmospheric pressure compensation hole. So you can imagine if water would move into this hole and would rest down here on the electrodes, it would generate a shortcut very easily, so the device would not work. Therefore, we have a very complex construction here to make sure that moisture is absorbed before getting through this little hole into the backside of the ceramic sensor. Benefits of the ceramic cell. Additionally, we have a self-monitoring function of the ceramic. So whenever the ceramic would break, the sensor would also detect a shortcut between the two electrodes and the process can be stopped immediately. So this is a very big advantage of the ceramic technology. It reacts much faster to any malfunctions than a metal sensor based on oil-filled capillary. And an additional advantage of the ceramic is that it's an absolutely vacuum-resistant concept. Due to the fact that there is no oil filling in, and oil always is somehow dependent also, so it evaporates if you increase the temperature or reduce the pressure. it would, at a certain vacuum level, the oil would start to evaporate. So this is not the case with a ceramic sensor. Moreover, the ceramic, we use a 99.9 pure ceramic, is very resistant against corrosion and abrasion. Corrosion is typically not a big problem in food and beverage industry, but abrasion you will certainly find, especially in yogurt production, where you have fruit pieces in the process, or where you have chunks of ice, for example, or fibers, which may abrade a very small and thin metal membrane. So ceramic is here much more resistant. The ceramic offers a very high accuracy and repeatability. It's very pressure shock stable, and therefore it can be used also in applications where you have kind of pressure shocks, for example, steam injections and applications like this. Also, the 0-point stability and the long-term stability of this design is outstanding due to the big surface of the ceramic. We have a very high performance measurement here. Last and not least, of course, like all the products we offer for food and beverage industry, also the ceramic sensor is of course certified by EHEDG and 3A and complies to the common food standards. So we talked about the condensation tight sensors. Here you see some typical applications where the condensation resistance is necessary, especially of course tanks where you have storage of cold medium, like maturation tanks of beer, or tanks where soft drinks are stored, where you have a permanent cold temperature compared to the outside atmosphere. Both technology are suitable. You can use the metal device, or you can use the device with the ceramic sensor, the PMC51 or the FMB 70 or 50. These devices have proven a very good resistance, especially for such applications. But Endress Hauser offers a portfolio of totally 4 different sensor technologies. So the two, let's say, high sophisticated designs we have already seen, the ceramic and the condensation tight contact sensor based on the piezoresistive elements. Besides that, we have also other technology which are based on the piezoresistive metal diaphragm. And I'm going to give you a little overview about the advantages and disadvantages of the other technologies. But finally, actually, all these 4 technologies make sure that you always will find the best fitting sensor technology for your application. So another picture of the 4 different sensor technologies in our pressure portfolio. You see here our very famous pressure M class. So this is the mid-range family, the mid-range segment, where you can find 4 different types of sensors built in one transmitter design. This is the compact metal cell, the diaphragm seals, the contact sensor, and the ceramic cell, which is also available with condensation tight design. So coming to the compact metal cell, this is again the view that we had in the beginning, the schematic view of the pressure sensor, now a little bit more clear or more concrete how it looks like in our instruments. We have here the heart, the sensor element, the piezoresistive chip. There is the process membrane, typically a stainless steel membrane with 25 micrometers thickness to be able to react flexibly to pressure changes, and an oil-filled channel or an oil-filled capillary. So this whole system is actually built up in one unit. here you can see how this piezoresistive chip looks like, and the basic function is it's a strain gauge technology where we measure different resistances, and the changes of the resistance are also proportional to the change in pressure. We also have a temperature measurement on board of this chip, so to be able to compensate temperature changes fast, because temperature changes have an effect on the volume of the oil, and any volume changes of the oil will have an offset effect on the measurement. The advantage of this technology is that you can get a very high variety of different process connections for this. This is a clamp, just as an example, but we have also many other process connections, may it be a Varivent or SMS or different hygienic thread connections. So the variety is very high to match, I would say, more than 90% of the applications in food and beverage. This sensor is suitable for temperatures up to 130 degrees. So normally in food and beverage, these applications we can easily measure. For the cleaning cycle or for the cleaning process, we can short term up to 1 hour also resist up to 150 degrees temperature. Diaphragm seals, this is the PMP55. They are also based on the piezoresistive sensor chip. And for this construction, we use a compact piezoresistive sensor and connect it with different adapters to the process. So the diaphragm seal, this is actually a very variable mechanical system that you can get in different sizes, made of different materials, with different membrane materials as well. And this, of course, offers the full flexibility for any kinds of process connections that you require. Also, an additional function is, for example, temperature spacers that can be added, or capillaries if you want a remote measurement. Nowadays, remote measurements are normally not done anymore with oil-filled capillaries. Our transmitters offer also an electrical remote system. So this means the sensor remains in place in the process, and with a cable, you can mount the transmitter part in a safe place apart from the core process. Only in applications where the temperatures are above 150 degrees, or let's say 130 degrees, then you should use the diaphragm seals today. The standard compact metal sensors are, for food and beverage, normally sufficient. So the diaphragm seals have one disadvantage. You can see here the upper part, the red part, is the normal piezoresistive sensor, the compact sensor, which already contains a process membrane. Then we have the diaphragm seal system here on the bottom, which has, of course, also a process diaphragm, or a diaphragm which is in contact with the process, and an oil filling. And this oil filling can be made from different materials. For food and beverage, of course, we use FDA approved oils. The disadvantage of this system is whenever the basic membrane, the process membrane, would break, the instrument, the sensor part, would not be affected. So the device would still measure continuously. Nevertheless, for example, if you imagine a dairy application, if the sensor is broken, milk could penetrate into this channel and contaminate over time your process without being seen by the instrument. And that's the disadvantage of the diaphragm seal systems. They are not self-monitoring. It may take some time until a malfunction or a defect of the device is recognized. The ceramic devices in this case offer an immediate response after a sensor breakage. To summarize the four technologies, so the compact metal cell, as I mentioned here, based on the piezoresistive technology, is actually the basic device. It's also the most cost-effective instrument in this line, and it's suitable for most of the applications in food and beverage. It offers also very small process connections down to 1/2 inch with a flush mounted membrane. Diaphragm seals should be used for applications whenever the temperature of 130 degrees is exceeded. We can go up to 400 degrees in case temperature spacers and capillaries are used. Here we have the highest variability with process connections and materials as mentioned. So whenever this guy is not suitable anymore because the matching process connection is not available, you can go for the diaphragm seal devices. The contact sensor and the ceramic sensors, as said, they are fully condensation tight. The contact has the best temperature shock behavior of sensors in the market, so it's recovering very fast from temperature changes. On the other hand side, the ceramic cell offers the self-monitoring function and is a vacuum resistant device. The oil freeness is also an advantage, but mainly for the life science industry. When you can imagine today now with the coronavirus, everybody wants to develop the vaccines, and if you want to measure pressure in such an application, of course you don't want to have a contamination by oil. A ceramic sensor is completely oil free, and life science customers, they prefer this kind of technology for the very valuable life science processes. So the segmentation of our portfolio, we differentiate between a process line for the applications in chemicals, in oil and gas, or also in the mining, mineral and metal industry, and the hygienic line, which is suitable for food and beverage and life science industries. Also, in terms of the functionality, we have different degrees, starting with the very basic Cerabar without a display, with a basic functionality, no display, and a very compact design, to the Cerafund, which offers display functionality and a switch output. Today, the Cerabar M and the Delta Pilot M are in food and beverage the most common products. And Delta Pilot is the premium device with the highest accuracy, with a double chamber housing and a temperature compensated electronics, which improves also accuracy slightly. This is all about pressure. If there are any questions in the audience about pressure, we can answer them now. Otherwise, I will move on with...
Either you have been so clear or nothing open.
Nothing open. Okay, I will continue. There is just the possibility to answer questions later on. When we talk about point level, we talk about limit detection. So we don't talk about a continuous measurement anymore. We talk about a switch device. So for example, the vibration fork technology, which I would like to start with. This is a technology which was introduced by Endress Hauser into the market in the 1970s already. Today, it's a very established technology used in most of the industries in many applications because it's a very universal technology which offers a lot of advantages. We have actually two different types of sensors. The Liquifund sensor, as the name says, is used for liquid application, and the Solifund is used for solid applications. Both work on the vibration fork measuring principle, so we generate a frequency around 1000 Hertz on the two vibration forks, and when you immerse the device into medium, the frequency in case of the Liquifund or the amplitude of the signal when you use a Solifund is changing, and this change of the amplitude or of the frequency will be detected by the electronics and will generate the output switch. This device is a self-monitoring design, so it means it's a permanently active device which all the time controls its function. So this means even if you use it for high level applications, whenever the device would have a defect, it would immediately indicate that. And a mechanical switch, of course, is not able to do that. So what are the advantages of the Liquifund when we talk about liquid applications? First of all, you can use it as a plug-and-play device. You don't have to calibrate it. You just mount it in any position you would like. You just have to consider, do you want to use it as a high level or as a low level switch, and connect the output accordingly. All the rest is not of importance anymore. So it's a very universal. We have the permanent self-monitoring functions. Also, it's a completely integral sensor. So this means the whole device is made from stainless steel. There are no seals, there are no plastic parts. It's completely stainless steel. Also, in case something would break off from the device, it could be detected, for example, easily in a metal detector. On the other hand, the process parameters don't affect the measurement. If you have air bubbles, foam, or suspension, it doesn't affect the device. So the device will only see the liquid level, and normally foam and air bubbles are suppressed. Also, if you have buildup on the fork or fouling, as long as the fouling doesn't block the whole sensor, so this means the complete forks are covered, the device is still working, and it reacts still to the liquid surface changes. Conductivity, a very important point, especially when we talk about capacitance or conductive switches. Conductivity has no effect on the device. So if you have changing media between cleaning cycles and processing cycles, the device will not be affected by the change of the conductivity or the viscosity of the medium. As long as the medium is pumpable, the device will also switch reliably. And even though it's a vibration fork technology, so we talk about the frequency, external vibrations of the plant have no effect on the measurement. Also, very high temperature and pressure applications are no problem. We have suitable devices which go up to more than 200 degrees and 100 bar pressure. Here is an example of a fermentation tank. You can see this is a beer fermentation tank. There is the draining line, and at the bottom of the draining line here, we have installed the device. Normally, when you drain a beer tank, there will be always foam left inside the pipe, and this foam will not affect the device, so it will not measure the foam. It just reacts on the liquid. The Solifund for solid applications, here you can see some examples, is normally used in all kinds of silo material, grain, flour, cacao, sugar, animal feed, but also milk powder can be measured. Also very light medium, like fine powder with a lot of air inclusions is easily measurable. We can measure down to 50 grams per liter. So this is a very light medium, like the aerosol that you find normally in the chemical industry. So to round up our portfolio, we also have devices for capacitance and conductive measurement. These devices are called LiquiPoint. And like many others, we offer also a device based on a very basic technology. We have a peak cap here in front of the sensor, and we do a capacitance measurement. This device is very price attractive, and it's useful for applications where you have water-based media. The disadvantage of this technology is that whenever the medium properties like the conductivity or the dielectric constant are changing, the device needs to be readjusted. So this means a manual adaptation of the device. This has to do with the technology, and of course it's not always very user-friendly. When you have conductive medium and it's based on water, then it is also easily usable. The advanced function you will get when you go for the FTW33. This is a multi-parameter sensor, so it has two electrodes measuring capacitance and conductivity at the same time. And with this kind of technology, we are able to adjust automatically also to changing media. So you can measure also non-conductive media here. Here you can see also applications where we have sticky or a media which is tending to form buildups. Also, this is no problem for the FTW33 because it has an active buildup compensation. So up to 1 centimeter of buildup on the process surface will not be detected as filled medium. So this is a real plug and play device without the need for any readjustment. So as I mentioned, it's a device which can be used in water, but also oil-based media, so non-conductive media. We have a fully flush-mounted installation. Here on this picture, you can see nicely how it is installed in a tank. For example, if you use wipers inside the tank to wipe off the material from the tank walls, you can easily wipe over the device without harming the measurement. This is of course not possible with a vibration fork or with a device with a peak cap on top of it. We also offer a wide range of process connections, so to adapt it to any process. And we have also, like on this picture, weld-in adapters to weld in an adapter where you can screw in the device. The housing is IP69, and of course its temperature can be up to 150 degrees for up to 1 hour. Another function that we offer with this device is the foam measurement, foam detection. So you can have 2 modes in the device. The first is to detect just the liquid level, like in our case with the beer. We detect only the liquid layer. But if you change the function mode to the extended mode, then you will be able also to detect foam. For example, in fermentation tanks where foam generates and rises up to the top of the tank, it can contaminate, for example, pipings, and it's quite a price intensive and cost intensive process to clean all these piping after foam has contaminated them. So to use this device on the top of the tank to detect the foam helps to reduce operational costs in this case. So the adjustment can be done with a magnet. You just hold it on the side of the device and you can change the function mode, either sensitive to the liquid or sensitive to the foam layer. This picture demonstrates very nicely how the buildup compensation works due to the fact here you can see the 2 electrodes, or actually it's 3 electrodes with the ground electrode, how the compensation works. So both these coatings will not affect the reliability and the measurement of the switch. So all in all, we have typically 3 different technologies used in the food and beverage industry. This is 2 conductive and capacitance devices and the vibration fork. From a segmentation point of view, we promote the FTW23 for simple applications. It's a cost-effective device for water-based media. The Liquifund is the most universal, price-wise also very attractive, and it can be used for any kind of pumpable media, may it be conductive or non-conductive. And the specialist is the FTW33, which is used when you have heavy buildup, when you need to detect foam, or if you want a really flush-mounted installation. Here is an overview of the applications that are fit for the 3 different technologies. By the way, here you can see the process connection with the so-called Welding Adapter. It's a 3/4 inch Welding Adapter, and devices can be exchanged easily. So if you find out the FTW23 is not so suitable for the process, you can easily exchange it by a Liquifund or by an FTW33 without changing the process connection. Yeah, this is just an overview. You see FTW23 is just suitable for the water-based applications. The Liquifund has for many different types of media is suitable there only if you have a very viscous medium which tends to generate a lot of buildup. Then you should go for the FTW33, which is sufficient in these applications. As a conclusion, whatever application you may have in your process, you will always find the best fitting solution from the Endress Hauser portfolio. You don't have to be fixed on just one technology. You can choose the best fitting one from the portfolio, and the availability of a high variety of different sensor technologies makes sure that you don't have to make compromises on reliability and durability of your instruments. I'm through with my presentation. Are there any questions from the audience?
So thank you very much, Ralf. There are, let's say, 2 questions you could maybe talk quickly a little bit about. And one customer even knows about the QMW43 and was asking if this is not an instrument also to mention in your switches part. Maybe you can say 1 or 2 words about the QMW43.
Yes, I don't have a slide for the QMW43. The QMW43 is based on the sensor design of our FTW33, but the QMW43 is not a level switch. It's actually a device which can measure the amount of buildup in front of the sensor. So this means the FTW suppresses the buildup to be able to measure the real level in the process. The QMW43 offers an output which gives you an indication about how much fouling or how much of buildup is remaining on the sensor, for example, after cleaning. So you can optimize cleaning processes by installing different devices on different critical places in your process. And it helps, of course, to reduce the cleaning cycle times and to improve the profitability and efficiency of your plant. But since it's not a level switch, I didn't talk about it today. It's a device which we call a device for inline quality measurement or for the measurement of product properties. So it's rather in this segment of applications.
Right, but maybe good to mention on this seminar for the others as well, that we have something like this. And then maybe the last 2 questions are more based on the sensitivity of the Liquifund. So there are questions on, is, for example, foam or turbulences, or if there are agitator inside, what is the effect? Is there an effect on the measurement with the Liquifund?
Of course, the changing density of the medium affects the vibration frequency of the vibration fork. So I'm talking about 1000 Hertz when the medium is in air, when the device is in air. When the device is in the medium density affects the vibration frequency. That's why you can use a Liquifund also to measure density of the medium. This is another product which I'm also not talking about today, but when you use it as a switch, there is a certain threshold value where the device will still switch, even though if the densities of the medium are different, or there are gas bubbles inside, which also change, of course, the vibration frequency, but the device has a certain threshold, a certain range within it is detecting the medium as being present and switches very reliably. So there is no need to worry about reliability in the process like that.
All right.
I hope the question is answered.
I think so. So this was the last one. Then if you can go to the next slide. So how to go on now. As mentioned, we have the recording of this seminar. So what I did on the handout, so please, if you are interested on the handout, make the download now, because when you just look the recording, you are not, you will not be able to download the presentation. So therefore, please do it now. But you can see the recording later on. So just follow us on www.endress.com, and I put the link to the online seminars already there. There you will find, let's say, the next seminars from Endress Hauser, which might be not for the food and beverage industry, but they might be for other industries or for products. As well, you can see the recordings, and of course you can download or can see the other recordings of all the seminars we had already. As I mentioned at the beginning, this was a series of seminars we had in November for the food and beverage industry. So we did start with let's say the toolings, how online toolings can help the customers to operate their plant, even in common situations now when people cannot enter the plant, when people have to stay at home because of an illness or because of this COVID-19 situation, if there is a lockdown organized by the government. So this was the tooling, the first seminars. And then we have been talking about analytical instruments, how the analytical instruments help in the productions. Then we talked about the flow devices, we talked about the temperature devices, and today, the last one, we talked about the level and the pressure devices. Please do not hesitate in any case, if you have any more questions, to contact one of us or to contact your organization, your local organization for help. We will organize new seminars in the next year. Of course, we like to do as well let's say the customer seminars where we travel around or where we invite the customers, but in case it's still a lockdown or a lockdown area, we will organize online seminars as well next year. We are going to inform you early enough for registration, and we would be glad if you then come to us again for the news and the updates. For now, I would like to thank you for your participation and your interest, and thanks for your time spending with us for this presentation, and I hope we could give you some news and some hints to operate your plant in a better way. Thanks from my side, and have a good night or a good day, and or a good morning and a good evening. Bye-bye. See you next time.
Thank you. Thank you. Bye-bye.